what we want to do in this first problem here, number 17, is determine if this relation, right, a set of ordered pairs is a relation, if it's a function. Now a function does this. It takes each, let's draw a picture here. Here's what a function does. It takes each element in the domain and maps it to exactly one element in the range. So for example, in this one, this 8, right, the first components are in the domain, the second components are in the range. So what this one does, this takes 8 and maps it to, now, does that 8 go anywhere else? No, 8 goes only to -2. Now what about the 4? The 4 goes only to 0, the 9 goes only to 3, the 5 goes only to 9, and the 1 goes only to 1. I'm going to draw a different picture here. I'll draw the domain elements. Now the domain elements are the first components, the 8, the 4, the 9, the 5, and the 1. All right, so here's the domain elements. 8, 4, 9, 5, and 1. The domain, the range, these are the second components. -2, 0, 3, 9, and 1. So it's -2, 0, 3, 9, and 1. And now the relation does this. It maps an 8, it takes an 8, converts it into a -2. It maps a 4 over to a 0, and only 0. 9 goes only to 3, 5 goes only to 9, and 1 goes only to 1. So this relation is a function because one domain element, one element here, goes to exactly one element here. And in fact, here's the domain, right? So the domain, I'll just write it here. Here's the domain. This is the collection of first elements. So the domain is 8, 4, 9, 5, and 1. And the range, that's a collection of second elements. That's going to be -2, 0, 3, 9, and 1. Now this problem 19 is similar to the last one. Look what we have here. Here's the domain. All right, the domain, this is the first elements. What we have, a 4, a 0. Okay, I got a 4, a 0. Now, I already have 4, so I don't need to write it again. What are the first components? 4 and 0. Now, what's the range? That's the second elements. 6, 4, 7. All right, so the range, 6, 4, and 7. And now, is this or is this not a function? Well, look at this domain element 4. Where does it get mapped to? Well, 4 goes to 6. Well, okay, 4 goes to 6, right? 4 goes to 6, but what about over here? 4 also goes to 7. So 4 also goes to 7. So right away, this is not a function. Now, it turns out 0 goes only to 4, but the problem is that the 4 goes to 6 or to 7. It's ambiguous. What we want is one element in the domain going to exactly one element in the range. But we have this one element going to more than one element. So this in the range, so this is not a function. Now, what do you think about this problem number 21? Look where 2 goes. All right, so what's the domain elements? Let's write this and find out where. Here's the domain and the range. All right, so what do we have? Here's the domain. First components, 2, 5. Well, there's that 2 again, right? We've already written the 2. So what's the range? Well, the range is the second element. So we've got a 4. Now we have another 4 here, but I don't need to write it twice, and we have a 3. All right, so 2 elements in the domain, 2 in the range. Now where does the 2 go? The 2, right, according to this here, the 2 goes to 4, and the 2 goes to 3, all right? So 2 goes to 4, and it goes to 3, so it goes to more than one element. So this is not a function.